Hello again, and welcome back to Semester 11 Math. Today, we're continuing our talk about sequences and series. What we know so far is we know our basic definitions, right? We know what a geometric sequence is, and we also know what a series is. But today, we're going to combine the two, and we're going to talk about geometric series. At first, we're going to go through a derivation of the formulas, and then from there, we will attempt to do one or two questions involving geometric series. So as promised, we're going to start off with our derivation of our formula. So geometric sequences, by definition, a geometric sequence has the same common ratio, right? It has the same common ratio. So consecutive terms are all multiplied by the same R value or ratio to get the next term and so on, right? We know this through our definitions that we studied previously. So by definition, a geometric series, right? A series is just the sum of a sequence, could be denoted as a r to the 0 plus a r to the 1 plus a r squared and so on, all the way to a times r to the n, right? A being our first term in our sequence, r being our common ratio. So our very first term, our ratio is raised to the power of 0, giving us just our a value, right? So this actually is a series because I included addition, right? So this is just the general form. So let's denote our series with S sub n, right? We did this with arithmetic sequences and series, and we're going to do it with geometric as well. So what I want to do now is I want to multiply both sides by r. I want to multiply both sides by our ratio. So on the left, I'll simply have r s sub n. And now going forward, if I'm multiplying each term by r, what's going to happen? Well, our exponents are going to increase by 1 for each term. So for our first term, we're going to have a r to the 1 plus a r squared plus a r cubed and so on until we get a r to the n plus 1, right? This is just utilizing our exponent rules to do the multiplication across the board. Okay, that's great. But now what? Well, now I'm going to want to subtract r s sub n from s sub n. Okay, so I'm going to have s sub n minus r s sub n. So I'm subtracting 2 from 1. Okay, so this is 1, this is 2. When we do the subtraction, we're going to want to subtract the same terms. So here, I have a in red, I have a times r to the 0. In blue, I do not have that same term. So we're just going to leave it. We're going to have a times r to the 0. And now, going forward, I'm going to subtract, again, the same terms. So if I have a times r to the 1 minus a times r to the 1, well, those cancel out, right? Those cancel out. Conversely, ar squared subtracting ar squared, well, they're going to cancel as well. And now you can envision that this is going to happen across the board, all the way, even with ar to the n, that's going to be somewhere in our series, leaving us with ar n plus 1. Leaving us with ar n plus 1. Now I left it as a subtraction because remember, we're subtracting 2 from 1. Okay, that's great. Now what can we do? Do you see anything that we could do? Yes, we could factor. So in our first part here, we're going to factor out s sub n. So if we factor out s sub n, we're left with 1 minus r. ar to the 0 is simply a, right? Anything raised to the power of 0 is 1, leaving us with a. So what can we do here? Well, we could also factor, right? We could also factor. So we're going to be left with a bracket 1 minus r to the n plus 1. Almost done. And now we're just going to isolate for s sub n. Now we're just going to isolate for s sub n. And to do so, we just divide both sides by 1 minus r. So we're left with a 1 minus r to the n plus 1. All over 1 minus r. And that's it. This is going to be the formula that we are going to use when we are looking for geometric series, when we're solving for geometric series. And now we should know how to use this formula just by looking at it, right? Nothing changes. S sub n is simply the sum. A is our first term. N is our term that we're summing to. And R is our common ratio. So let's go through a few examples on using this formula. So this question here is asking us to determine S sub 10 of the following sequence. At first, we're going to want to determine if this is a geometric or an arithmetic sequence. Obviously, since we're talking about geometric sequences in series, it's probably going to be geometric, but we need to double check. So to do so, we want to find if there is a common ratio. So we simply take our second term divided by our first term, which gives us 2. And then we take our third term and we divide it by our second term, which also gives us 2. Therefore, we can confer that the common ratio is 2. Okay, great. So we have our formula that we derived. All we do now is we plug in our values. So we have a is equal to 2 because a is our first term. Our common ratio is 2, and n is 10. Why is n 10? Because it's asking for the 10th term, the sum up to the 10th term, right? S sub 10 is the sum of the first 10 terms. So, like I said, all we do now is we plug into our formula. S sub 10 is equal to 2 bracket 1 minus 2 raised to the n plus 1, so raised to the 11th power, all over 1 minus 2. And now we just take out our calculator and we solve. So this is going to be 2 times 1 minus 2048, all over negative 1. So 1 minus 2048 multiplied by 2 gives us negative 4098 all over negative 1. Our negatives cancel out. So we're left with S sub 10 is equal to 4098. Now, if you don't believe the formula or you don't believe your calculations were correct, you can go ahead and determine the next 10 or the entire sequence up to the 10th term, and you could add them up manually, but I promise you will get the same answer of 4098. Let's go ahead and try one more. Again, we're going to want to determine if this is a geometric sequence or not. Our process remains the same. We take our second term, divide it by our first term, giving us 0.5 or 1/2. And then we take our third term and divide it by our second, also giving us 0.5. Therefore, we can confer that our common ratio is 0.5 or 1/2. Great. What is our first term? What is our a value? Well, that's 3. And it's asking for S sub 100. So it's asking for the sum up to the 100th term. So our n value is 100. Now for this one, you're not going to want to determine the 100 terms in the sequence and add them up manually. So you're going to want to revert to the formula. Simply put. So let's go ahead and do so. S sub 100 is equal to A, which is 3, bracket 1 minus R, which is 0.5 or 1/2, raised to the exponent n plus 1, so raised to the 101th power. Great. This is all divided by 1 minus 0.5. Again, all we do now is we take out our calculator and we solve. So 0.5 to the exponent 101 is an extremely small number. 3.9 times 10 to the minus 31. All over 1 minus 0.5, which is simply 0.5. We continue to compute on our calculators. 1 minus a number this small, we could say is 1. We could say that this approaches 1. So 3 times 1 is 3, divided by 0.5 is going to give us S sub 100 to be 6, or to be approximately 6, right? Because we did an approximation, but 6 is a pretty good answer for S sub 100 of the following sequence. And that's it. So that's all there is to determining geometric series. All we do is plug into our formula